Hello everyone, my name is Dr. Vile and welcome to my A-Level Chemistry YouTube channel. The purpose of this channel is all about getting you ready for your A-Level Chemistry exams. And with that in mind, this video is going to focus on acid-base chemistry, more specifically looking at the differences between strong acids and weak acids, and we'll do some calculations related to those. So if you find the video helpful, remember to like it, subscribe, keep checking back for more content as this page is being updated regularly. So before we get into the difference between strong acids and strong alkalis, we need to consider what pH is. You're probably very familiar with the pH scale, which goes from 1 to 14 and is a measure of how acidic a substance is, where 7 would be bang in the middle, and that would be a substance that is neutral. So we start at pH 1, which would be a strong acid, and then pH 7, that is our neutral pH, through to pH 14, which would be a strong alkali. However, at this stage, we don't really know what these numbers actually mean. They're a measure of acidity, so you could either use something like universal indicator to do this, so that would give you nice colours from red, which is your strong acids, through to purple, which is the strong alkali, green would be neutral, and then yellow and orange would be in between the strong acids and neutral, and then blue would be in between neutral and strong alkali. So you could use universal indicator or indicator paper, but more precisely you'd use a pH meter. And that's kind of what we're going to focus on in more detail, because pH is actually a measure, a mathematical measure of how many hydrogen ions are in solution. So pH, the formula that you need to know for this, is equal to minus log of the concentration of H+. So if you know the concentration of H+ ions that are in solution, you can calculate the pH and vice versa. So if you need to go from pH back to H+, then what you do on your calculator is you press shift, then log, and then it would just be minus whatever your pH value is, and that'll give you the concentration of H+. So you can convert between pH and H+ relatively straightforwardly. So let's start using this information to look at some problems. We're going to start off with a nice straightforward situation, which is where you have a strong acid. So an example of a strong acid could be something like HCl. Another example could be nitric acid, HNO3. Or sulfuric acid, H2SO4. These are all examples of strong acids, but what do we mean by a strong acid? Well, let's just take the HCl as an example. When you put hydrochloric acid in solution, it fully breaks down into hydrogen ions, H+, and chloride ions, Cl-. This is not a reversible process like we'll see with the weak acids. It's irreversible, so it completely dissociates into H+ ions, and therefore the concentration of the HCl equals the concentration of H+ ions. So therefore, if you know the concentration of the HCl, you can calculate, well, you can more than calculate, it's done for you. You can work out the concentration of the H+ ions and hence the pH. So let's just assume now, let's just make up an example, that the concentration of the HCl is 0.15 molar. Therefore, the concentration of the H+ ions must be 0.15 molar. The capital M just means moles per decimeter cubed. And therefore we can work out the pH, because we know that pH is minus log of H+, which is 0.15. and this comes out as 0.82. And pH has no units. So to summarize here, if you have a strong acid fully dissociates into H plus ions, and therefore if you know the concentration of the acid, you can just find that on the bottle. You know the concentration of the H plus ions, and therefore you can calculate the pH very straightforwardly. This is in contrast to a weak acid. Now, a weak acid is something that doesn't fully dissociate into H plus ions, but something that partially dissociates into H plus ions. So if we take an example, such as ethanoic acid, CH3COOH. Now, when it dissociates in solution, it dissociates reversibly to give H plus ions and ethanoate ions. Because it dissociates in a reversible way and an equilibrium is established, the concentration of the H plus does not equal the concentration of the ethanoic acid. But what we've done is create an equilibrium, and therefore we can say that Ka, which is your acid dissociation equilibrium constant, is equal to the concentration of the H plus times the concentration of the ethanoate ion, CH3COO minus, divided by the concentration of the ethanoic acid. So whenever you have a weak acid that's dissociating, it's always products over reactants. So it's the H plus ion times the counter ion here, which is the ethanoate ion, divided by the original concentration of the acid. For the purposes of calculations, we can simplify this. Because it dissociates equally into H plus and ethanoate ions, we could say that Ka is equal to the concentration of the H plus squared, because they're basically the same number, divided by the concentration of the acid. If you're asked to write Ka for a specific acid, make sure you write out the full equation, but it's okay to use this shortened version when actually doing the calculation. And therefore, well, we're going to see a problem in a minute. We're going to use this formula to work out the pH of a weak acid. So here we're saying you've got a solution of ethanoic acid that has a concentration of 0.12 molar. Calculate the pH of the solution, assuming that Ka is 1.78 times 10 to the minus 5. So in this situation, we'd start off by saying that Ka equals the concentration of the H plus squared divided by the concentration of the acid. See the earlier section on the video if you're wanting to see where that came from. We then need to rearrange this equation to make H plus the subject to the equation. So we start off by saying that H plus squared is equal to Ka times the concentration of the acid. However, we want to have H plus on its own, and it's currently squared, so we have to square root both sides of the equation. And therefore we can say that the concentration of H plus is equal to the square root of Ka times the concentration of the acid. And at this stage we're ready to start plugging some numbers in. So it's going to be the square root of Ka, which is 1.78 times 10 to the minus 5, times 0.12, which is the concentration of the acid. And when you chuck that into your calculator to three significant figures, that comes out as 0.00146. And therefore pH is minus log of H plus. So that gives us a pH of 2.84. So as we close, I just want to look at one more little term in this video, and that is called pKa. Before we get into pKa, just remind yourself what Ka is. Ka is your acid dissociation constant for a weak acid. And the bigger the value of Ka, the stronger the weak acid. So not all weak acids are equal. You get stronger weak acids and weaker weak acids. I know it sounds a bit confusing, but you can have strong weak acids and weak acids. And the bigger the value for Ka, the stronger the weak acid is. However, the numbers for Ka are huge, and they can range a lot. So they could be anything from 10 to the minus 8, 10 to the minus 2, 10 to the minus 5, etc. So actually, to give us more sensible numbers, just like with pH, we use the term pKa. And pKa is minus the log of Ka. So minus log of Ka. And what this means is that if Ka is a bigger number, then pKa would be a smaller number. And if Ka is a smaller number, then pKa would be a bigger number. So the smaller the value of pKa, the stronger the acid would be. So just to try and summarize that, when you have a small Ka, that means you'd have a bigger pKa, and therefore you'd have a weaker acid. And when you have a bigger value for Ka, that means you'd have a smaller value for pKa and a stronger acid. But bear in mind, when we're talking about pKa, in general, we are talking about weak acids, so acids that only partially dissociate. We are not saying that they are actually strong acids, because remember, a strong acid fully dissociates into H+ ions. Anyway, thank you for taking the time to watch this video. I hope it was helpful. Please remember to like, subscribe, and keep checking back for more content, and I'll see you next time. Thanks, everyone.